Hello students, now we will see the next example in method of sections. I hope this session is going to be interesting for you all because I'll be taking method of joints as well in the same example. You can see that this is the next example. Now in this it says that determine forces in the members BD, CD and CE by method of sections. That is BD, this member CD and CE. So I can take one single cutting plane in this fashion and find out the forces in these three members. But after that, the question also states that forces in remaining members by method of joints. So whatever is left out, you need to solve for those members by using method of joints. So first things first. Now, as I have already clearly explained you all this, that first step is always to find out the stability criteria. In few of the previous examples, I haven't taken that, considering that you have already got used to this habit of finding the stability criteria. The second step is always to find out the support reactions. Support reactions in this case, at joint A, I have a hinge support and at F, I have a roller support. So two reactions over here and one reaction at F. Horizontal and vertical at A. So first thing is the stability criteria. I hope that you can do that now. The next is applying condition of equilibrium to find out the support reactions. I'll just show you what I have written till now. Since there is no horizontal force in this given example, the horizontal reaction at A would be 0. Now, the vertical reaction forces, that is VA, VF, has to balance out the four vertical forces acting at B, D, C and E. That is 1200, 600, 400 and 200. So that is in the vertical direction, that is for Fy. Now, the next step that I'm doing is taking moment about A so that I can find out the reaction force at F. Now, if I do that, if I take moment about A, horizontal force, the moment will be 0. The reason, it is passing through the moment center. Vertical reaction force at A, again 0. The moment will be 0 because it is passing through the moment center. Now, I have four forces, all are acting downwards. So with respect to point A, all the four forces are going to create a clockwise moment. Whereas the reaction force F at F is going to create an anti-clockwise moment. The distances are clearly mentioned for me, so I can take the distances and the forces and find out the moment with respect to point A. I've got the reaction force at at F, the vertical reaction force at F as 1200 newtons. Since the answer is coming out as positive, that means my assumption of the reaction force acting upwards is correct. So I can just show that with an arrow over here. Now, I need to find out the reaction force at A. So what I'll do is I'll substitute this value in this equation and find out the reaction force at A. So that I'll get it as again 1200 newtons acting upwards. So I have found the support reactions for the given truss. Now the first part of the question states that by using method of sections, we need to find out the forces in BD, CD and CE. For that, what I'll do is I'll take a cutting plane. I'll cut the truss into two like this. So I'll call this cutting plane as 1, 1. Now, I'll just draw the left part of the truss first. So now I need to find out the forces in the members BD. I'll call this as F1. In CD, I'll call this as F2, and in CE, I'll call this as F3. The distances are given to me. This distance is 15 meters, 15 meters. This is 20 meters, and this is also 15 meters. Now, what I'll do is, I'll take moment about point C. If I do that, I'm taking moment in such a way that the unknown force F2 and F3 is becoming 0. The moment of these two forces is becoming 0 because they are passing through the moment center. Now, F1 is the force which is inclined at some angle. So I need to find out angle of this force. I'll call this angle as, say, alpha. So if I find out the angle, I can resolve this force F1 in horizontal and vertical components, and then I can take moment about C easily. To find out the angle alpha, I know this length is 20 meters and this is 15. I know that even this is 15 meters. So I can just say that this length up to this point M is 5 meters. So I can find out the angle alpha. I got the angle alpha as 18.43 degrees. Now I'll take moment about C. Taking moment about C. This force, the moment will be 0. 1200 Newton force, even that will be 0. I have this one force, 1200 Newtons, acting vertically upwards, so that would create a clockwise moment. So that would be negative 1200. The perpendicular distance is 15 meters. Now, once I have resolved this force with respect to at this point B, so F1 vertical component, that would be again 0 because that is also passing through the moment center. So this force, that is the horizontal component of F1, is going to create a clockwise moment. So minus F1 cos of 18.43 degrees into 15 equal to 0. I'm getting this as negative. That means it is a compressive force. So F1 is a compressive force, and F1 is nothing but the force in the member BD. So I'll just write over here equal to F BD. Now, the next step that I can do is I can take moment about A. If I take moment about A, I'm creating this moment, the force of this moment, the moment of this force as 0. But in that case, I'll be increasing the calculations because I cannot make this as 0. So I would prefer taking the method of joints itself here. Now, if I take method of joints, for only this part of the truss, not the right side part, only the left part of the truss. So what is going to happen? How many vertical forces I see over here? The left part is going to have this 1200 Newton force acting vertically down. this 1200 Newton force acting vertically upwards, this is also acting downwards. Now, the unknown forces would be F2 and F3 because I have already got F1. So if I take method of joints at, if I just apply condition of equilibrium, now I'm just stuck over here for the angle of force F2. Now, how to find out the force of this? I mean the angle of this force. If I just draw a line over, if I just check this is 15 meters and this is 20 meters. So I have the distances for me. Now I can do that over here. Tan of beta is this 20 opposite side by the adjacent side. So that would be 20 by 15. I'm getting beta as 53.13 degrees. So I'll just take the sine component because I'll just take the sine component. The reason for that is I'm not taking the horizontal direction over here. I have the y direction force. So that is F2 sine 53.13 equal to 0. I have got the value for F1. F1 is 1260, a compressive force. Now understand this. This is a compressive force. I have assumed F1 to be acting outwards. So since I'm assuming F1 to be acting outwards, the magnitude at this in this direction would be negative. So I'll take a negative sign for that. So I'll just cancel out this because plus 200 minus 200 cancels out. I'll have 400 minus 400. F1, as I said, is a compressive force. And since it is a compressive force, I have resolved it as a tensile force. So I have to take the magnitude as negative. So I'll just do that. So it will be minus 1260.5. Now you can see that I have got the value for F2 as 997.9 newtons. So I have already calculated this force now. If I take the condition of equilibrium for the horizontal direction, I can find out F3 force now. So I'll just write that equation. If you look in this figure, there is no actual horizontal force acting on this truss. All I have the vertical forces acting and the vertical reaction force. Now what I need is the horizontal component of this force, horizontal component of this force to balance out. This F3 will be there. So what I'll be doing is I'll write the equations. I'll write the equation for F1 and F2. I have the angle for that and with F3 in that. I just hope that you are not getting confused because of this negative sign over here. As I've already said that F1 is a compressive force which I have found by calculations, and over here I'm taking F1 as a tensile force. So when I'm resolving it, it is going towards the positive side. So the magnitude should be negative. So you can see that I have got the value for F3 as negative. That means it is a compressive force. The nature of the force in the member CE is compressive. So by using method of sections, I have found the forces in the three members that was required. Now I'll move on to method of joints. So I'm done with three members, that is BD, CD and CE. Now if I take joint A, what happens at joint A? That is, I'm moving on to the next part of the question. Now joint A, I have only two unknown forces, that is AB and AC. So I can apply condition of equilibrium over here and find out the two forces. The angle of the force AB will be 45 degrees because this length is 15 meters and this length is also 15 meters. The nature of the force in the member AB is compressive. Now if I substitute this value over here, I can find out the force in the member AC. So this equation will become I'm getting the force in the member AC as 1200 newtons and that is tensile. So by method of joints, at joint A, I have applied condition of equilibrium and I have found force in member AB and AC. Now I'll move on to the next joint, say F. If I move on to next joint F, the unknown forces will be FD and FE. Now I'll have to find out this angle theta. Now I know this length is 10 meters and this is 20 meters. So I can apply trigonometric ratio over here. So I've got the force in the member FD as compressive and the value magnitude is 1341.6 newtons. Now I'll apply the condition of equilibrium in the x direction. I'm getting the force in the member EF as tensile and the magnitude is 600 newtons. So by using method of joint at F, I have found the force in the member DF and EF. Now what is left out is ED. I can take joint E and find the force in the member DE. Now in this case, I can directly apply the special case. I'll just show you what is happening over here now. This is the special case at joint E. We have seen that in this type of a special case, what happens is whatever the force you have in this direction, the same force will be that on this direction as well. And in this direction, you have 200 Newton force, so DE will be also 200 Newton force. So I have to just verify what I have got over here. I have got EF. In the previous sheet, I have solved that. EF, I'm getting it as 600 Newtons. And you know that in the member CE, by method of sections, we have calculated the force. So I'll just verify that now. You can see in this sheet, by using method of sections, F3, I have got the value as 596.6 kilonewtons. So that means what? The value that I have got as 600 newtons is very much close to what I have got. Now, I'll move on to the next part, that is this. If I solve for this, I can directly state that FDE will be 200 newtons tensile. So this is how I have calculated the forces in all the members. So this is the unique example wherein you had to solve the forces in all the members by taking method of joints. I mean the forces in the remaining members by method of joints, and in the few selected members by using method of sections. Thank you.